Today we'll be talking about descriptive statistics. So, statistics are measures like simple mathematical formulas that can be calculated from the data to describe the data. That's why we call it descriptive statistics. We can create summaries of the data or other descriptions of the properties or characteristics of the data set that we believe would be useful to us. Descriptive statistics can be categorized. One category is the measure of central tendency, and another category is the measure of variability or spread. We will see examples of both of those shortly. So, the measures of the first one, the central tendency, will include descriptive statistics such as mean, median, and mode. The variability or variance would include measures such as standard deviation, variance, minimum and maximum variables. So let's see some examples of these. So the descriptive statistics is used by many researchers to describe data of what in statistics is called population or sample. Population will be the entire data set, and sample is a portion or a part of the data set that we can pick to experiment with. So if we don't want to do analysis on an entire huge data set, we can take part or small part of the data called a sample or a subset that we can start our analysis from there, like a small experiment. So statistics are widely used by researchers in various disciplines, including in social sciences, political sciences, as well as computer science and data science. So, because descriptive statistics allows us to summarize the information, it assists us to speed up and simplify the understanding of the data analysis. So, the comprehension of a group of characteristics or descriptions, properties of the data. So, what is a sample? What is a population? As we just mentioned, the sample is a small part of the entire data. So sample will be a subset of the entire data set. While the population will be the complete data set. Let's look at some examples here of the descriptive statistics. This is a simple data here that shows two groups. The first group is called class A and the second one class B. This is showing the intelligence coefficient or IQ of these students in these two classes. So we would like to create a summary of the group because we could have individuals with variable properties or characteristics within the group. But these numbers here are the IQ measure of the 13 students in the class A, and these numbers here are the IQ measure of the students in the class B. So what can we do? What kind of descriptive statistic we can calculate from this? We can calculate the average IQ for the first group, which will be 110.5, and the average IQ for the second group, 110.23. This allows us to look at overall, if we take this entire group's IQs, what will be the average number. It appears that both of those classes are very similar, have a very similar value. What else can we calculate other than the average? There are a couple of other measures we can calculate, but calculating this kind of measures, the descriptive statistics, would allow us to organize the data. We can organize in a tabular format or as a graph. As we discussed last time, most of the data are in a table format that have rows and columns, but there are certain data that come in a graph, such as social networking data. One friend connects to another friend, so there is a graph node or a circle that has an arrow pointing out of it towards the other graph node or circle that's their friend. So the graph can be used to represent social networks, computer networks, and even web pages on the web, because they have links in between each other, so that the arrow from one page would point to another one which contains a hyperlink to it. So as we mentioned in the first lecture, there is a lot of data that is in a tabular format, such as retail, financial, medical data, educational data, so that would be the most common format, but we also have data in other formats. For example, the graph, where would be Facebook data, computer networks, our World Wide Web data. World Wide Web pages. We could summarize the data by calculating average, or we can try to find some central tendency in the data and then the variation from that tendency. So the descriptive statistics would allow us to do this. So in tables, we could calculate the frequency distribution, we can calculate the bar chart or histogram. There's some also other visualization called stem and leaf plot. Also the frequency polygon. So let's see some more examples here. This is an output for frequency distribution. So frequency is how frequently or how often a specific data item occurs or specific property of an item occurs within the data. Whenever we plot this frequency, the resulting visualization is called a histogram. So the histogram shows the frequency of specific record, object, or property of the object. So here are the IQs or intelligence coefficient for our classes that we were seeing earlier. And then we can see how frequently this particular IQ is occurring. So for example, you can see that the 93 occurred twice, as well as the 131 occurred twice, while everything else is occurring only once. So these, the 93 and the 131 would have a higher value within our histogram. So if we are to visualize the frequency of the IQ, it would look like this. We have frequency 1, frequency 2, frequency 3, and then the IQ is on the bottom. So this is a very nice visualization of how frequently particular intelligence coefficient is occurring within our data. Other statistical measures that we mentioned here that we can calculate is the mean, that what you see down here, and the standard deviation. That is how much items would deviate from the standard. So this right here, SPSS, is a statistical software called Statistical Package for it computes certain statistical measures. It's a very classical statistics software that has this particular histogram or visualization was generated using the SPSS software. So here's another histogram that shows the frequency for our IQ measures for the two classes that we have seen in the beginning. That's a different visualization called the bar graph. So the bar is showing the number of students in the two classes. So we have class A and class B. Both of them had the same number of students. So that's why these two bars have the same height. So the count is shown over here on the left side, that is on the vertical axis, and we can see that both of these bars have the same height because the number of students in two classes was the same. Other visualizations, statistical measures that can be computed, that we can visualize, are the stem and leaf plot. So if we are to visualize this we can visualize the stem and the leaf as well for the particular data that we are calculating. Okay, that's yet another chart created by the statistical software that's called the frequency polygon. We have on the vertical axis the count, and on the horizontal axis the IQ numbers. So this is the same representation as what we have seen onto the histogram. That is, particular IQs happened twice in our data, and that's why you have this spike here. Most of them happened one time, but there were two IQs that happened two times, and that's where you see the two spikes over here. If we go back to our data, it's 93 two times, 131 two times. So that is what we are seeing here in these spikes. There are a couple of other measures that can be calculated, as we have just seen on the side of one of the graphs. There is the mean, that is the average. Median will be the center point of the data, and mode is the most frequently occurring item or object or number and description of the data. So these would be a part of the central tendency, and then the variation we have seen earlier on the side of our graph, something called the standard variation, standard deviation. So that would be how much the numbers would deviate from the center. So the mean, also called the average, would be taking the average number, so the sum of all the numbers divided by the total number of items. So that would be the mean. The variable, I said numbers, they could be numbers, it could be x, q, or it can be a symbol like the smiley face, or it can be anything, it can be an object. So whether that's a numeric or it is categorical, such as some description of the object, blue eyes, brown eyes, glittery eyes, so that's already a description that's not in numeric form, but it's a categorical description. Whatever it is, we can compute the mean for it, or the average. So what would be the mean of all these numbers? You just add up all the numbers together and divide them. That will produce the number 1437, and divide them by the total number of items, or students in this case, and that produces the average. Same for the other class. So here's the type of visualization we would have with the mean. 17 units, 21 units. And what is the mean? So the mean here is 110. It's a possibility of a skewed mean. Instead of mean being in the center, it can end up being on one side or the other. The reason for that is if one point is way out of range compared to the rest of the points, when we add them all together and take the mean, this one point that was out of range affects everything else, affects the mean calculation. The median, on the other hand, would be the central point. So the median would not be affected if one variable was much out of range, the same as the mean would be affected. Because the median just takes the center place. If these are all the points, that's the median, the one that's just in the center of it. Or we have 6 cases above it and 6 cases below. So then these one points that is way out of range compared to the rest of the points, for example, people's age. Let's say if we're looking at age of the people, and no, most of the people are of age between, most people in our data are of age between 21 to 88, for example. And then all of a sudden we have one person is of age 300. 333 years old. Is this possible? Everything is possible. There is a person of 333 years old age in our data. Well, that's an outlier. If we're going to take the mean, the average between 21 and 88, and one of them is 333, guess what? Our average age is going to be like 200 years old. That is way incorrect. That's and ends up skewing the mean out of its normal values. So with median, that is not going to happen because we just take the point that is in the center. So we'll have between 21 and 88 and then the 333 in the end of all of this. That doesn't matter. We take the point that's in the center, so our calculation is not affected, but it can be skewed like from an outlier like this. That's completely possible. So for that reason, we can calculate the median by taking the center point, or we can calculate something called mode. The mode would be the most frequently occurring item. So if we are to look at all these numbers, we will notice that the number 109 happens 3 times in the data, and it's the only one that happens 3 times. There are some numbers that happen 1 time or maybe 2 times, but 3 times this is the only one. So that would be the mode would be the most frequently occurring number. In this case, mode here is 109. Okay. So this visualization here, where we have seen the spike for number 2 because we had 2 items occurring twice. That is, they were the most frequently occurring. All the others were occurring once, and these occurred twice. So that's why we had those spikes. So this right here is a visualization of the mode measure. Okay, so that is all that we have today for the descriptive statistics visualizations.